Hi guys, hope you're all doing well today. I just wanted to remind you of a couple things. So first of all, your homework assignment is posted on the board. You can move the screen when I'm done with the video. It's over here on this side of the board, or on this side of the screen, on the behind that. So make sure that you look at that, take a picture of it. It'll also be posted in Google Classroom, and I'll send it out in Remind. And also don't forget that everybody needs one of these papers right here. And you're going to find those on the table right here underneath the screen as well. So make sure that you pick one of those up. And I'll see you guys on Monday. Have a great 3-day weekend. All right, so the one thing I want to talk about on this with you is not the transformation stuff, because I'm a firm believer that you guys are rock stars. This transformation stuff, we've been doing it for a long time. The big thing that we want to pay attention to with this is that anything that's horizontal is anything that is inside the root symbol, inside the radical symbol. So in this case, it'd be all of this b times x minus c stuff. So anything that's inside the radical symbol, inside the square root symbol, is your horizontal transformations. The other thing I want to talk about is I want to talk about what it means when it says that our domain and our range when n is even. So n is the number that's here on the outside, but I need you to know something. If you don't have a number there, so like if you just have like this, let me write that in a little bit different color there. If you just have like we'll say square root of x minus 3, I want you to think about what I just called that. I called that the square root. The reason it's called the square root is because there is an implied and understood 2 here. So if there is no number there, that number is understood to be a 2, and that's incredibly important that you understand that. So basically, all of 11.2 is about square roots, which means that in that case, n is even. So I'm going to address what this whole idea of our domain bit is and what our range is, because I think that's going to be the two things that are confusing here. So when we're talking about our domain, how we find it, I want you to either get a highlighter or something to underline this or color it or highlight it, circle it, whatever you need to do. This part right here, where it says 1 over b times x minus c is greater than or equal to 0, is referring to all of this. When you need to find your domain, you have to take what is under the square root symbol. Ooh, that's a terrible color. Hold on. There we go. You have to take what is under the square root symbol, and you need to set it greater than or equal to 0. And you actually have to solve that. So I'm going to do one of those because I want you to understand what it means. But that's how you find your domain. The reason that you have to do that is because think about what you're taking the square root of. You can only take the square root of positive numbers. So what's underneath the square root has to be positive. That's what we're saying when we say that it's greater than or equal to 0. We're saying that whatever's underneath the square root has to be positive. So what could x be in order for that to be true? So on page 593, I'm going to find my domain. So in order to find the domain, I have to take what's underneath the square root symbol, whatever that happens to be, which in this case is x minus 2, and I have to write x minus 2 is greater than or equal to 0. So to find my domain, I have to take whatever is underneath the square root and write that is greater than or equal to 0. Then I have to solve. Well, to solve, I add 2 to both sides, and I get x has to be greater than or equal to 2. So that is my domain. My domain is x's that are greater than or equal to 2. To find the range, it says that we look at a. We just look to see, is a greater than 0? Which, remember, if it's greater than 0, that means that a is positive. Or is a less than 0, that's when you have a negative a. That's really what you're looking at. So in our case, a is negative 3. So that means my range is going to be y's that are less than or equal to. And then I use d, whatever d is in this case, whatever my vertical transformation is. And that's where I get my range from. So range would be y is less than or equal to 3. Okay, so I'm looking at problem 5 on the next page, and again, I'm going to be finding my domain. So to find my domain, I need to take whatever is inside the square root symbol, so 1/3 times x plus 2, and I have to set it greater than or equal to 0, and then I need to solve. Well, most of you are like, oh, I just need to distribute. I need to distribute. Yeah, you can, but then you end up with fractions, and we hate fractions. So remember that on this left side, I'm multiplying by 1/3. So if I want to get rid of a 1/3 that's multiplied, I can divide both sides by 1/3. And 0 divided by 1/3 is 0. So I end up with x plus 2 is greater than or equal to 0. And I actually don't even need those parentheses anymore. And then I can solve. So that's easy to solve because I'm minus 2 from both sides. And for my domain, I end up with x has to be greater than or equal to -2. Then to find my range, I have to look at a couple things. First of all, I have to look at this number here in front, whether it's positive or negative. There's no number there. That means it's a 1, so it's positive, which means y is going to be greater than or equal to. And then I look at my d value here, whatever I shifted, however much I shifted the graph up or down, and that's where I get the rest of my range from. So my range of that problem would be y is greater than or equal to 1. All right, moving on to page 595. So I'm going to talk about problems 6 and 7, which are the only two that we don't know how to do, which is problems 15 and 17 from this assignment from 11.2 and problem 13, I believe, from 11.4. So I'm just solving for something, which means I need to plug stuff in. This is more about learning how to manipulate equations than it is about actually getting the equation or the graph. And just like before, and you probably figured this out, that I'm going to use this ordered pair here as my h and my k value. So that ordered pair is 1, -1. And then I'm going to need another ordered pair, which I thankfully have one here, which is 1.5 and 0. That is going to be my x and my g of x. So then all I have to do is just plug a bunch of stuff in. So it says g of x, well that's 0, equals the square root, remember there's a 2 here, this is going to come in handy in a second, of 1 over b, because I don't know what b is, times x, which I know is 1.5. If you're not sure where I'm getting that from, pay attention to the colors. Minus, wait, hold on, I'm not going to put that yet. So for h, I need to put this 1 here, but remember when it goes in here, it's the opposite sign, so it'll be a -1. And then close the parentheses, and then outside is k, which k is -1. And k is -1 because this was -1 right here. So that -1 gave me k, gave me this -1 here. It's very, very, very important. Make sure that your square root symbol extends through your parentheses, but it does not keep going. I don't want to keep drawing this because this -1, this k value, is not underneath the square root symbol. So now I just get to do math, which math isn't terrible. Well, I don't think it's terrible. I know you probably do, but we're going to agree to disagree on that. So I have 0 equals the square root of 1 over b times 1.5 minus 1 is 0.5 minus 1. So I need to get b by itself because that's what I'm looking for. I treat this just like I would any other equation. So I need to get rid of this -1 here. And I'm going to get rid of that by adding 1. Remember, you cannot just add this, subtract this 1 from this 0.5 for 2 reasons. Number 1, this 0.5 is underneath our square root symbol. Number 2, this 0.5 is attached to a 1 over b. And this -1 has neither of those properties, so they definitely cannot be combined. 0 plus 1 is 1, so 1 equals the square root of 1 over b times 0.5. And now the question is, how do you get rid of the square root? And this is kind of where the new stuff comes in. It's really easy, though. To get rid of a square root, you do the opposite of square rooting, which is to square both sides. Because when you square a square root, they cancel each other out. So on the left side, 1 squared is still 1. On the right side, our square and our square root symbol end up disappearing. They cancel each other out. So I'm left with 1 over b times 0.5. So to get b by itself, I just need to get rid of the 0.5. So I'm going to divide by both sides by 0.5. And I get 2 equals 1 over b. And then I can do some cross multiplying because, I don't know, I think cross multiplying is pretty easy. So I'm going to make that into a fraction and put 2 over 1. Cross multiply, I get 2b equals 1. So divide both sides by 2, and I get b equals 1/2. So then my actual equation, because that's what it really wanted, would end up being y equals the square root of 1 over 1/2 times x minus 1, and then minus 1 outside the square root symbol. That would be my entire equation. You could also, if you wanted to, you could write your 1 over 1/2 here as 2, because if you divide 1 by 1/2, you are going to get 2. Either is acceptable, but that would end up being my answer to that problem. So I'm going to do the same thing for g of x, except this time I'm looking for a, which let me tell you, looking for a is a lot easier, because you don't have to deal with fractions, you don't have to deal with all kinds of stuff. So again, kind of our vertex-y-ish point here is going to be h and k, which that is the ordered pair -3, 5. And then they gave me another point here, which is the ordered pair -2, 2. And that is going to be x and y, or g of x and x. So if I start plugging in what I know 2 equals a, I don't know what a is, times the square root of -2. And then don't forget this minus h means the opposite of h, so the opposite of -3, which is +3. And then I'm going to have +5 on the outside. Again, make sure that your square root symbol stops where it needs to stop at the end of the parentheses and doesn't keep going. So I'm just trying to figure out what a is. So I need to do some math here, which we just love doing our math. So I need to get a by itself. I'm going to minus 5 from both sides, and I get -3 equals a times the square root of -2 plus 3 is 1. I can actually figure out what the square root of 1 is. The square root of 1 is 1. So really I now have -3 equals a times 1, or -3 equals a. So see, that was so much better than the last problem. So that means my equation is y equals -3 times the square root of x plus 3 plus 5. And that'd be your answer. So not terrible. We're going to look at one question off of 11.4 just to talk about what you do to get rid of it when it's not a square root. So I'm going to look at question 5, and I am on page 629 of 11.4. I'm on page 629 of 11.4. I'm going to look at problem 5. I'm going to give you a minute because I know that you're trying to like flip through your pages. I can hear the pages turning. Okay, hopefully you're there by now. So again, I'm writing this function. I have a graph. I'm always looking for kind of like what my vertex-ish point would be if we had a vertex. So hopefully you can see that's this point here. That's going to be our h and our k. And that as an ordered pair would be the ordered pair -2, -5. Make sure that you pay attention to your scale, because in this graph, these are counting by 2s every time. So that's why I knew this was -2, and then down here this would be -2, -4, and -5 in the middle there. So that's h and k. I have a couple other points that I can pick from. I'm going to pick this point because it just looks a little bit better. The numbers do to me, at least. I can see for sure what they are. It's not in the middle of the graph. I like it a little bit better. So that point is going to end up being my g of x and my x, which would be the ordered pair 6, -1. So when I go to plug stuff in, I have -1 equals the square, a, because I don't know what a is, times the cube root, that's how we say that, is the cube root of x minus h. So that would be for us 6 minus -2, or 6 plus 2. I got to switch that sign there. And then plus k, so -5. And I get to do some math. So I have -1 equals a times the cube root of 8 minus 5. So I need to get a by itself because that's what I'm solving for. So I need to get rid of that -5. And to do that, I'm going to add 5 to both sides. So I get 4 equals a times the cube root of 8. And I would use your calculator to figure this out because we don't deal a lot with cube roots. And some of you are like, oh, I know what the cube root is, no big deal. Others of you are like, I don't know what the cube root is. So to do the cube root in a calculator, you go to math. I don't know which button it is underneath math, but I know it's underneath math. So you can hit math and then there's a cube root option there. But the cube root of 8 is 2 because 2 times 2 times 2 is 8. So really our problem is 4 equals a times 2. And then we're trying to get a completely by itself. So I'm going to divide both sides by 2. And I end up with a equals 2. The same thing would be true on B, except in order to get rid of your cube root symbol, eventually you're going to have to cube both sides of your equation. So the only other thing just wanted to remind you of is that on cubic functions, which are the ones where we are doing a cube root, our domain and range are both negative infinity to positive infinity. So it's kind of nice because you don't have to really think about anything or do anything. Oops, there's a typo on here. That should for sure not say that the range is negative infinity is less than or equal to x. That should most definitely say the range is less than or equal to y. So you can go ahead and fix that one. But that's the only thing I wanted to tell you. So this assignment is due on Monday. Make sure you write the assignment down. And I'll see you guys on Monday. Have a great 3-day weekend.